am Dharani, working as the assistant professor in SNS College of Technology in the Department of Food Technology. I am going to discuss about terminal velocity. Terminal velocity is the constant speed that a freely falling object eventually reaches when the upward force of air resistance balances the downward force of gravity. At this point, the object ceases to accelerate and falls at the steady rate. Force acting on falling object. Gravitational force. This is the force exerted by the Earth's gravity on the object. Fg equal to mg. M is the mass of the object. G is the acceleration due to gravity, approximately 9.81 meter per second square. Drag force. This is the force exerted by a molecule on the object opposing its motion. Drag force depends on the several factors: speed of object, cross-sectional area, drag coefficient, air density. Speed of the object. Drag force increases with the square of the velocity. Cross-sectional area, the area of the object facing the direction of the motion. Larger areas encounter more air resistance. Drag coefficient, a dimensionless number that depends on the shape of object. Air density, the density of the air through which the object is falling. Drag force can be expressed as Fd equal to 1 by 2 rho v square CD into A. Achieving terminal velocity. As an object falls, it accelerates due to gravity and the velocity increases. Consequently, drag force increases. Eventually, the drag force becomes equal to the gravitational force and the net force on the object is 0. At this point, the object stops accelerating and continues to fall at constant speed, known as terminal velocity. Setting a drag force is equal to the gravitational force. Mg equal to 1 by 2 rho Vt square C into CD into A. So, terminal velocity Vt equal to root of 2 mg divided by rho into CD into A. Factors affecting terminal velocity: mass, cross-sectional area, drag coefficient, air density. Mass, heavier objects have higher terminal velocity because gravitational force is larger. Cross-sectional area, objects with large areas experience more air resistance and thus have lower terminal velocity. Drag coefficient, streamlined objects with lower drag coefficient achieve higher terminal velocities. Air density, terminal velocity is lower at higher altitudes where air density is less as air resistance is lower. Example of terminal velocity: skydiver. A typical skydiver in a belly to earth position reaches a terminal velocity of about 120 mph in a head down position, which is more streamlined. The terminal velocity can be increased to around 150 to 180 mph. Raindrop. A typical raindrop has terminal velocity of 9 meter per second. Practical implications: engineering, the design of vehicles and aircrafts involves minimizing drag to achieve higher speeds or reduce fuel consumption. Thank you.